Hi, this is Maggie from Design Code Debug Repeat. If you're a beginner programmer, a beginning game programmer, a programming teacher, or if you just find this content interesting, please consider subscribing to the channel. I'll be posting lessons, tips, and cool programming stuff regularly. I recently asked my students to write a game in which balloons with prizes in them drift across the screen from left to right and wrap. If the user clicks on a balloon, the prize falls realistically to the bottom of the screen. I saw an interesting error that I wanted to share with you, as it allows us to think a little bit about how the game loop should be structured. So this is the program with the error in it, and let's just run it first. So this isn't the student's program, this is just a simpler example. So in this example, I have an image from NASA, and I also have this rocket image which I got from Wikimedia Commons. And I've also got these flickering stars in the background. Now the rocket, as you can see, drifts across the screen or flies across the screen, and then it wraps once it reaches the right edge. Now in the program I asked my students to write, they would click on the object drifting across the screen to make it fall. Here I'm just going to process a click, which is a good way to develop the program incrementally. Once you've got it just responding to a click appropriately, then go ahead and get it to respond to a click that's actually on the object. So I'm going to click, and you can see that the rocket did not fall realistically. It just sort of hovered in midair, stopped, and then suddenly was on the ground. And this was an error that one of my students had, but several students encountered a similar issue. So let's look at it one more time. You might also have noticed that when the rocket stopped, before it dropped, that all the stars stopped flickering. So let's just talk about the program briefly, just so you have a general idea of what's going on here and how it's structured. So we have our assets, we load in the assets, and for the stars I'm just randomly generating locations, 50 locations on the screen that are mostly above the moon's surface. And here's the important part. So we have our game loop, which begins with while not user quit. And user quit is a variable that we set if the user clicks in the close box. Let's see if the user can quit while the rocket is dropping. So it let me quit once it had dropped, but it was not responding to my click. So you don't want to do that. You don't want to make your program unresponsive to user input. So why is it doing that? Why isn't the rocket dropping? So we've got the game loop, and then inside the game loop, we've got the event loop, where we're getting the events off the event queue. And if there's a quit, we set the user quit flag to true. Now, if there's a mouse button up, that means the user has clicked. And here's roughly the way the code was written, that my student had written, is they had a loop in here where they keep adding the change in the rocket location to the rocket, blitting the background, and then blitting the rocket back over the background. And they did that until the bottom of the rocket touched the bottom of the screen. Now I should mention, at the point that I assigned this problem, we hadn't yet covered sprites. So we're basically handling all of that sprite information in separate variables. So we've got the rocket, which is, here we're blitting it down here at the bottom of the game loop. The rocket is the surface, the pygame surface, and rocket X and rocket Y are the location of the rocket. So ignoring the clicking code, the way the program works is each time we go through the game loop, which should be 30 times every second, we're adding a dx, a change in the x coordinate of the rocket, to rocket x. And then we're doing some boundary checking. If rocket x, which will be the upper left of the rocket, reaches the screen width, then we set it to appear to start to come from the left side, so 0, which is the coordinate of the left side, minus the width of the rocket. And then we blit the background, blit all of our stars, and then blit the rocket. The way that we're making the stars appear to be flickering is that I'm just changing the size of the stars, so they're just randomly somewhere between 1 and 3, and they're just circles with a random radius between 1 and 3. So that just, each time through the loop, they're probably going to blit as a different size, or they have a 1 in 3 chance of blitting as a different size, so they appear to flicker. So this, ignoring this loop here, this is the way that you should set up your game loop. You get your events, and then you do any processing that you need to do in the background, and then you draw stuff. So why isn't this working? Now, something that a student tried was to flip here as well. So, we're blitting the rocket moving, but we're never flipping the display, so we're not seeing it. So they might add pygame.display.flip here, and let's see what that looks like. By the way, I've made the rocket fall at a steady velocity. It's just steadily falling 1 pixel. I did that to make it move slowly so it would be easier for us to see. So if you're developing this program incrementally, then you want to get the broader parts working first and then go in and focus on the details. So I would say, just get it processing a mouse button, then worry about whether the mouse button is in one of the objects that's floating across the screen. And just get it to fall, then worry about getting it to fall realistically using some sort of equation that takes a gravity into account. The other thing that we might do here, actually let's do this before we flip the display, is we can throw some print statements in here. So are we actually getting into this loop, and what is rocket Y? If we are in this loop, what is rocket Y each time through? So let's go ahead and run it, move that over, and we'll see that print statement here. So I click, and we can see it increasing by 1, and then it falls. And so at this point, if we've done that debug code, we know we're getting in here, we know it's increasing, we're not seeing it, then we might have the brainstorm, I need to flip the display. So let's try that. Okay, now it is falling. Totally lose my flickering stars, and I would not be able to process a click in the close box. Okay, processes it once it falls. So what's going on? Well, the error that you want to avoid is putting a loop within your loop. So there may be situations like here where I'm looping through the stars to draw them, where you have a very quick loop, but you don't want a loop that's doing processing that you should be doing each time through the game loop. So what we really want is, for each time through the game loop, we want our rocket to drop a little bit more. And that way, we'll still be flickering the stars, and we'll still be processing a quit from the user. So let's say if we are going to develop this incrementally, let's think, what do we want to happen when the user clicks? When the user clicks, well, we want the rocket to stop moving right to left, and we want it to start falling. So we might set our rocket dy, and we might set our rocket dx to 0, which we are doing here, so that it stops moving to the right. Now, if you are going to do some kind of realistic falling, you probably are going to keep both x and y components for that motion. But for now, we just want it to drop just straight down. Let's just get that working. But we don't want to do this. Let's just comment that out. So suppose, let's see here, we're setting rocket x plus equals rocket dx. Well, that's okay because it's still 0. Maybe we want to add the rocket dy. So maybe we want to do the same thing. Rocket y plus equals rocket dy, and then maybe do our check here. So maybe we could copy that, or we're going to do it. We want actually the opposite of that. That's okay. So we want to check if rocket y plus rocket.getHeight is greater than or equal to screen.getHeight. Then we're going to set the rocket y to 0 now because we're done falling. And then we are going to want to set that y so that it appears to fall exactly on the bottom. So we're just falling 1 pixel at a time, so that's probably not going to be an issue. But if we're falling more pixels at a time, we might fall below the bottom of the screen, so we want to just bump that back up so that we're exactly at the bottom of the screen. And so what happens if we run that code? So we can see our stars are still flickering. Can I quit? I can quit. Okay, let me speed it up a little bit. Let's make it 5. And we can see it lands. Now, of course, it's using the bottom of the image, which is, or the surface, which is this fire. So probably we would want to change this to a rocket that looks like it's landing, and maybe once we hit the bottom, I mean, there's a lot of animation that we could do. But now we've got code that works with the game loop so that we can still quit. We've still got the other background stuff going on. So if there were meteors or prizes, anything here that we wanted to detect collisions with, we want that stuff to keep moving around. And if there are other things that the user can do, if there were controls so that they could increase or decrease the amount that the rocket is moving by, we want the user to still be able to interact with those controls. So what we want to do when we're processing a user action is we want to set our variables here, but not go into some sort of loop. We want to set any variables. We might need to add variables. We might need to add a flag variable or maybe do even more complicated work here. But we want to just sort of set the stage so that when we get down to the drawing is correct. So in the event loop, we just want to get the user input and set our variables so that we can do our background motion, and then when we get to our drawing, which should happen 30 times a second in the game loop, we are drawing the current state of the system, which we've updated here in our event loop and here with our background processing. I hope you enjoyed this example, and I hope you found it helpful. If you did, please give the video a thumbs up and please consider subscribing to the channel. There'll be more cool stuff. If you have questions or comments, if you want to discuss this, if you experimented with it and came up with something else that was interesting or a way that you think is better, please comment in the comment box below. I'd love to chat with you. Take care.